You anywhere where you want to have them. Now, you're going to say, okay, thank you all, that's awesome, you know, but machine learning is never 100%. True, absolutely, right? It's there to take the majority of cases and understand what's going on. You know, majority of my documents, I recognize what's going on with my customer. Majority of my emails, I understand what's going on with our customer. But sometimes if I clean and curate that data and run my machine learning models, I might not have the right confidence, right? That's where accuracy or confidence scores come in with machine learning, right? They tell you, okay, I'm 90% confident it's you are the motive. Right? Now, I might say, okay, let's say 95%, for example. If it's above 95% confidence, I take action straight away because my machine learning gave me the insights that I want to have already. What if it's lower? This is where it falls back to human review. Right? So now I can have a human review on whatever is going on. From that, obviously take action. But in addition to that, use that to update my machine learning training data and optimize my machine learning for these additional edge cases that I previously didn't have. Cool. All right. Talked about a lot here. So how does that all work out when we think about data in a time manner, right? So what happened in the past, what happens in the future, where's time coming in here? So I'm going to try to draw this out again very conceptually onto my whiteboard, very high level, but just to kind of look at the different terminologies here and try to understand how does that all fit together. So let me switch over to my whiteboard application here. And again, you know me, we always start with the most important person in the room. Oh, there we go. There we go, a little delay. My whiteboard is a little bit slow. There we go. With the most important person in the room, which is my customer. Now I'm going to simplify this conversation. So we're going to, there we go. We're going to obviously talk about data. Now, don't blame me for drawing something that looks like just one data store. So assume this, as I mentioned earlier, many different data stores, many different places where my data is stored, but conceptually just look at it as one unit right now, right? So let's say my data stores that I have, you know, my customer is interacting with my website, with my application, etc. You know, and we obviously get something back in real time. So that's where this real time feedback comes in. That's where we talk about real-time data analytics, right? So that's good. You can give a good customer experience here, you know, based on, you know, I know your profile, so I'm doing this, right? But the other thing is with all these data sets that we collected, I showed you all the different data sources that we bring back in, you know, what can I do? Especially if you talk about operational efficiency. Sometimes maybe I want to run a batch job to understand what is happening here. We run a report. Hey, what was the sales number last quarter, right? That's batch operation. That's a reactive kind of way of looking into this. So let's draw that out here. I would call that reactive analytics, right? Think about the batch jobs that you might run, you know, maybe your business intelligence tool that I'm running. And from there, I start obviously getting insights of what happened in the past. And obviously my employees, and obviously use that, run a report, understand how our business is doing, understand the health of the business, understand what's going on in the past, because we understand what happened in the past. If we understand what happened in the past, we might be able to understand patterns. And if we understand patterns, we can potentially use that to predict the future. You guessed it right, that's where machine learning comes in. So this is where obviously predictive analytics comes in, right? So if you think about predictive here, so that's where my AI or my machine learning models come in. There we go. Little L, delay there. My machine learning models come in. And if I do these kind of predictions, I probably want to store some of these predictions. I'm going to show you a little bit later how that works in a different stores or maybe an API where now my consumer can interact with it. That's where, for example, a personalization comes in. I can also use that store to now say, maybe I only want to send you marketing material that's relevant to you. And of course, with all of that prediction, I might be able to streamline my operations a little bit better. That's really where all of this comes in. So let's talk a little bit about streamlining your operations. So let me close my whiteboard applications here. All right, quickly, just bear with me. There we go. There we go. Now, think about things like software deployment, for example, right? In Amazon, we're looking into when you actually commit code to a repository, it will automatically go out, right? And it will automatically be deployed, and if the error rates are increasing, you roll it back, right? Now, take error rates, for example. That's a perfect example of how we can use data and past trends, together with machine learning to understand if we deploy better auto not. This is very often referred to as an anomaly detection. Okay, take something very simple. Okay, here's my deployment, and I have an error count rate here. I do. Obviously there's always a bit of errors that's assumed. Certain systems fail, etc. But it's never probably zero. So I understand what's my average error count here? 16.4. What's my standard deviation here? Okay, 21.1. What's my standard deviation? I know if I'm roughly there, everything's kind of okay. Right? But what if that error count suddenly shoots up? Right? What if the error count massively goes up? Then my deployment has failed. There's a massive problem with that. Now this is a very simple example, right? I don't need a machine learning model to understand if I look at this graph, something is wrong. But this is a good example of sometimes simple metrics together with an anomaly detection function help me to immediately understand how can I do better. In this scenario, we looked at where's the problem. But that doesn't always need to be a problem. Sometimes that might be something, if my consumer is using my platform less, that's an anomaly detection. Maybe that customer is likely to churn. I want to send some marketing material. Well, that is where metrics come in, and Amazon Lookout for Metrics allows you to do anomaly detection on any kind of metrics that you're using, even third-party platforms, specifically SaaS solutions, your Salesforce, your Marketo. Taking that data, send it to Amazon Lookout for Metrics. It will now detect where are anomalies. Based on these anomalies, I might be able to then take action and say, hey, I send you an email, I send a Slack message to my team to improve something, right? Again, sometimes we don't need to go super complex. Just look at the metrics that you have. Do an anomaly detection. It already helps you to better understand your customer, helps you understand how can I be operationally more efficient. And talking about that, what about physical stuff? What if I have actual physical units somewhere in my manufacturing plant running around? This is very often referred to as predictive maintenance. Understand the anomaly before, when it happens, and then take action before my unit breaks down. Amazon Lookout for Equipment allows you to do exactly that with industrial machinery. Analyze sensor data from over 300 different sensors. Pinpoint where's the problem and find an anomaly. And of course, this integrates with, obviously our AWS IoT solutions like Sitewise, but also existing industrial monitoring software like OSI Soft, for example. Get that data, detect the anomalies, and then take action. Take, for example, Amazon itself in our fulfillment centers. Before we ship out a package, all of these conveyors are constantly monitored, right? And we actually run predictive maintenance on top of it. If this conveyor belt breaks down, so many packages are not getting delivered in time. That's not good. That's poor customer experience. We would predict something before it fails. But as a matter of fact, how are we going to ship it out? How do we choose the carrier that actually delivers it to your doorstep? Well, we only make the decision the very last moment before the package leaves the place. We call it SLAM, scan, label, apply, manifest. So the packages wait right before it takes out, and then we choose the best route and carrier. With a machine learning model based on data that's in real time, we know now this is the fastest and best and most cost-effective way to ship your package at this point in time. And only then we apply that label and manifest it accordingly. Now the other thing I talked about, personalization, right? What if I want to get access to a good way of providing better recommendations, personalization? With Amazon Personalize, you get access to the same recommendation and personalization engine that Amazon.com is using, without the need of having any machine learning expertise whatsoever. You just bring in your data, your events, your interactions, your views, your signups, you bring in the metadata, what's the detail of the products I'm selling, you user metadata, where they're based, etc. And then, obviously, the AI magic happens, so the machine learning magic happens. So you inspect the data, identify the features, select the hyperparameters, optimize the models, etc. But here's the key point. All the stuff you see here in the dashed line in that box, that's fully managed for you, right? Fully managed by Amazon Personalize. I don't need to figure any of that out. Just bring in my data and out comes an API that gives me a personalized experience. How about forecasting? Forecasting is super important, right? If I forecast better, I can be operationally more efficient. Now again, let's simplify this, right? Basic stuff, right? I look at my historical trends. Okay, I see here mountains and peaks during this times of the hour. I have more traffic, I have more operations in my supply chain, you know. If I know that, then I can maybe predict into the future. Now the problem here is if I predict into the future, what happens if I under-forecast? If I under-forecast, I have a problem. It's a missed opportunity. I might not be able to deliver the product to you. What if I over-forecast? Waste resources, right? You start paying for things, and when I say paying for things, this might just not just be your cloud. Right? It might be physical assets that I have lying around. Why, man? Like, we're missing out here. So if we more accurately get to what the actuality is and forecast that better, I can make better decisions and be operationally more efficient. How is Amazon doing that on their supply chain, for example? We automate fully end-to-end our supply chain. What does that mean? Well, all of our products are forecasted. Over 400 million products daily are forecasted. Where are they used? When are they ordered, etc. And based on that forecast, we actually order our inventory. Over 99% of all of our inventory is completely ordered automatically, and then an automatic selection of a machine learning model decides where do we place it so that we can fulfill your orders in a faster time at a very cost-efficient rate here. You want to get access to that? Great. That's where our AI services come in. Amazon Forecast allows you to get access to the same forecasting engine that Amazon.com is using without the need to use any machine learning expertise that you bring in. Bring in her historical data, your sales, your inventory, take the related data, what's the promotions that I maybe won, what's my stock data, what's my weather data, right? Well, maybe it's related to weather. If I deliver something out, if it rains, it might be different. What's my metadata, etc. Then again, if you look at the dash box here, not going into in details, but Amazon Forecast is doing all of that, Look at the data, identify the features, train the machine learning model, etc. But you just come out with one API that you now can get access to and say, forecast me this specific trend, forecast me what's happening next week. Right? And this is really where the machine learning stack comes in. So we look at the Zoli, we look at the top layer. Here I use things like computer vision, etc. to enrich my data, but now we also have access to capabilities to predict the future a little bit better. And if you say, oh, okay, thank you, Ollie, that's all cool and nice, but sometimes I want to build my own model. That's where Amazon SageMaker comes in. So it allows you to actually build, train, and deploy your own machine learning models with the help of proven and existing machine learning algorithms. So you don't even need to write your own machine learning algorithm. You just bring in your data, you train it securely in your cloud environment, right? And off you go, you come in with your custom model that you now built. And if you say, hey, I'm really good at this, I want to build my own model and algorithm from scratch, also fine. This is where obviously the underlying infrastructure and frameworks that we provide for you, or that we support, I should say, bringing down the cost of both inference and training. So in closing, before jumping to some of the questions that you have, which I'm going to look at, I really want you to think about building your data strategy, of course, based on outcomes. Customer experience is important. Drive operational efficiency. Don't just do data for the sake of data, right? Drive actual business outcomes here. But if we do that, there are many separate different data sources and data stores that we have, right? So looking to how can we use maybe fully managed services to drive insights from this first, second, or third party data, and then enrich different data sources that we have. Data comes in many different forms and shapes. Use AI and machine learning to really broaden your insights into the data sets that you have. And of course, let AWS do the heavy lifting for you. Now, before closing up, let's have a quick look at what kind of questions we have got from the audience. So let me slide over here to my colleague who sends over the questions here. So let's see. For example, let's start off with there's a lot of questions here. Wonderful. I love it. I love it. Thank you for the engagement. Now, for example, what is the difference between Athena and Redshift Spectrum? Very good question, right? Because Redshift Spectrum, if you're not familiar with it, allows you to actually run a SQL query that queries your data straight off S3, right? So I don't actually need to load it up into my Amazon Redshift data warehouse. Similarly, familiar Amazon Athena allows me to do exactly the same thing. So why do I have those two services? That's the question, right? Very good question. Well, Amazon Athena basically allows me to do it already. Redshift allows you to have columnar kind of ways of querying. So if you have a situation where you say, I have data sets where, think about it like one column, right? Give me the average of all of these sales data, for example. If you have these kind of queries, Redshift will perform a lot better and faster than Athena. So if you say, I don't know what my access pattern is, probably go for Athena. If you say, I have these columnar kind of access patterns, Amazon Redshift Spectrum still allows me to do it without loading it up into my Redshift cluster, but I get a better performance out there with my Redshift cluster. The other thing that I should mention, Amazon Athena is completely serverless, so you only pay for the amount of data that you query, where Redshift Spectrum, you still have Redshift nodes that you actually bring up, so it's not exactly kind of serverless, you still have nodes that you need to define. That's another thing you probably want to be aware of. Let's have a quick look. We got so many questions here. I'm trying to select. Let's see. When we use Amazon Elastic Cache, why is this low latency? Is there a specific reason for this? Fantastic question again. What's Amazon Elastic Cache? Amazon Elastic Cache is a fully managed service to do in-memory databases. So you have a choice between Redis and Memcache. And now, as the name indicates, it's in memory. So you store your data in memory, not actually at a storage disk. That allows us to access that data a lot faster. So this is very useful, obviously, if you want to have, when you have access patterns where say, I need to get this data really, really quickly, maybe even certain millisecond, like single-digit millisecond latency, that's where in-memory databases are very useful. Of course, as you can imagine, because it is in memory, it is somewhat volatile. There are ways to somewhat persist it. So again, you make the choices between how durable I want my data versus what's the fast access that I want to get to my data. So Elastic Cache managed service for in-memory database, and that's why it's low latency. I think we got time for one more question here. Let's have a look. Could you explain a business use case? Let's say you're getting data from different resources. Data contains things like hotel details. How do we predict hotels that are similar? What are the things that we have to take in? This is a good example because earlier I talked, we want to drive a business outcome, a business use case. I like this. Immediately, one of the people here on the stream asked about hotels specifically. Good. That's the way we want to think about data. We want to work backwards from an actual business outcome. Now, if you think about this, how can I predict better hotels for my customers? So again, first thing you do, you go first-party data. What do I have in my system? How do I know my customer? How are they, what's the past hotels that they maybe have booked? What's the metadata of the hotel? Where is it located? What's the location? Do they have a swimming pool, etc.? That's all first-party data. And now you continue to then enrich it, right? So that's the default, and then we go and enrich it. Maybe I have additional metadata information from other data service provider where I understand that customer a little bit better. Where, in the past in another system, the person has always booked something with a swimming pool. Great, then I recommend that. Right, so that's the way you want to think about it. Take data from a variety of different data sources, bring it together, and then personalize that experience, give and provide a better customer experience. Now we're slowly running out of time, but please keep your questions coming. I'm going to stay on the stream. I'm going to answer them. And my team behind are going to answer it, obviously textually. Unfortunately, here we run to the end of the stream. But again, I want to remind you, very important for us. Thank you very much for attending, but please complete the survey at the end of the session. Make sure that you let us know what worked well for you, what you want to hear more about, what maybe didn't go so well. Also hear the different handles and how you can reach out to us beyond just the platform that you connected in with here. And with that in mind, again, thank you very much for attending this live closing keynote of the AWS Innovate Data Edition. I hope this was insightful. If there are any outstanding questions, please keep them coming, and I hope to see you again next time. Thank you very much.